This is not, let's look at our integral here. This is not a rational function, right? So why are we even talking about it? Doesn't partial fraction decomposition only work for rational functions? Well, the reason why we're talking about it is because this integral is one step away from being a rational function. Here's what we mean. First, we're going to apply a u substitution. The result is going to give us an integral in terms of u and du. That integral is going to need partial fraction decomposition. We'll get an answer, and then we'll back substitute to get our final answer. Okay? So, first let's look and see what should our u substitution be. Looking at this, the denominator here looks like, let's just try to, this denominator, so if I've got e to the 2x divided by e to the 2x plus 3 e to the x plus 2, I can rewrite this as smiley face squared plus 3 times smiley face plus 2 over smiley face squared, where smiley face equals e to the x. So now how did I do that? Here's the key. The key or the trick, the hint, the key is to notice that e to the 2x is the same thing as e to the x squared, right? So now, when we rewrite this denominator, so let's say we're going to rewrite the denominator as, or rewrite this entire fraction here as e to the x squared over e to the x squared plus 3 times e to the x plus 2, right? So these are the same. And now, if I let smiley face equal e to the x, this shows how I go from e to the x to something that is clearly, this is clearly a rational function in smiley face. A rational function with a variable smiley face. So you say in smiley face. Okay, so this is the idea that we're going to use for evaluating our integral. So what we're going to do is we're going to say, let's set up a u substitution. So we're going to let u equal e to the x. Then what is du? Du is going to be e to the x dx. So our integral, which we should be able to just copy, paste. So our integral is going to be equivalent, using our u substitution, is going to be equal to, same thing as, the integral of, on top we'll have u squared, on bottom we'll have u squared plus 3u plus 2. But now what are we going to do about this dx? What are we going to do about the dx? Look back here. Dx is equal to, how do we get dx to be in terms of u? E to the x dx is equal to du, so we could say that du over e to the x is equal to dx, right? But now, again, this is not good. We can't stick du over e to the x into our equation, right, into our integral, because everything needs to be in terms of u, but we just remember that u is actually e to the x. So we can rewrite this as du over u. So dx is equal to du over u. So here, this dx, we can replace it with du over u. So I have du over u. And now the cool thing is that the u in the denominator is going to cancel with one of the u's in the numerator. And we'll have as our integral equal to the integral of u over u squared plus 3u plus 2 du. Okay, and now we proceed like normal. So we're going to say u over u squared plus 3u plus 2 It's a rational function and a proper rational function because the degree of the numerator is 1 and the degree of the denominator is 2. So we can go straight to factoring. And I believe on bottom we can just do u plus 2 times u plus 1. That's what I think. Okay. And on top is u. So now our form is going to be a over u plus 2 plus b divided by u plus 1. Okay. And so now I'm going to write this is equal to a times u plus 1 plus b times u plus 2 divided by u plus 1 times u plus 2. So u, right, so the numerator over
It's
here,
18 hours.
u has to be the same thing as all of this up here. A times u plus 1 plus b times u plus 2. Okay? And so I can go ahead and expand this. So I'll have au plus a plus bu plus 2b is equal to just u. Collect like terms, so a plus b times u plus a plus 2b is equal to u. Now, what are my equations? A plus b must be equal to 1. Why? Because this is the same as 1 times u plus 0, right? So a plus b has to be equal to 1. And then this 0 must be the a plus 2b. 0 is equal to a plus 2b. So I've got a system of equations, two unknowns. How do I solve them? I'm going to solve by substitution. Let's just do that. So a, from this second equation, I get that a is equal to negative 2b. And I'm going to take that and stick it into my first equation. So 1 equals a plus b, but a is really negative 2b, so negative 2b plus b is equal to 1. So now b minus 2b, that's negative b, is equal to 1. So then b is equal to negative 1. And now I hook this piece of information along with, right, I add these two pieces of knowledge to tell me that a must be, because a is negative 2 times b. If b is negative 1, then a is 2. Good. So a is 2 and b is negative 1. So I can go back here and put a is 2 and b is negative 1. Okay. For u squared plus 3u plus 2. All right. So now I am ready. Let me actually just take it and move that over here, because I am now ready to do my integrating, right? Because what I need to do is evaluate the integral of u du. Why do I need to do that? Because remember, we rewrote it over here, right? So this is our original problem in terms of e to the x. And then we, did a u substitution. Things canceled out. So we're looking at this integral of u. This is the integral we're looking at. Makes sense. Okay, so this is what we're trying to evaluate, because this plus this u substitution is going to give us this. Okay, so here we are. And I need the integral of this du. Now this, I'm going to do it kind of fast. Okay, so make sure you should pause the video, try to do it yourself, restart the video, and make sure that we have the same answers and the same process. That's another thing. It's not just about getting the right answer, it's also about communicating the work that you've done. All right, so this is what I got for my answer. Natural log of u plus 2 squared divided by u plus 1. Okay, so I'm going to go ahead and now I need to back substitute. So remember that u is really a stand-in for e to the x. So my overall for real answer, I don't know if you all are, if you're, okay. So you can say, oh, for real? That's what we used to say when I was a child, right? So it's a Southern thing. Okay. All right. So the for real answer is natural log e to the x plus 2 quantity squared over e to the x plus 1 plus c. And in fact, just to make it very, very clear that this is a natural log of all of this, I'm going to kind of relocate. And I'm going to put a box around this because this is our final answer. Okay? So let's just kind of review what we did, okay, because it had several steps. So the first thing we did was, so this was our problem, was to evaluate this weird looking thing. Why does it look weird? Because it's got e to the 2x and, it's like, what does this have to do with anything, right? Step 1 was to rewrite our integral as the integral of a rational function using u substitution. So this part right here was step 1. Okay? Now, and also plus, because we have to include the recipe that tells us how to go back and forth between our variables x and u. Okay? So that was step 1. Step 2 was to figure out the partial fraction decomposition, right? Which that in itself involves several steps. So step 1, you have to guess the form, right? You got to figure, step 0 is make sure that what you're looking at is a proper rational function. And then step 1 is you've got to set up your form, factor the denominator, figure out your partial fraction decomposition form. And then after that, you solve for the coefficients, right? And so that took us a little while. So we solved for the coefficients. And now, and then once we did that, we were able to plug it back in, right? So once we figured out A and B, we plugged that back into our partial fraction decomposition form. And then that gave us an integral. Now it's time for step 3, the third thing in our long process, which was to go ahead and actually evaluate. This is relatively easy. Usually I think that's a little easier than solving for the equations, but that's just me. It's your preference. And then once we did that, we got an answer, but our answer was in terms of u, so we had one more step to get the final for real answer, which was to back substitute to get our final answer in terms of x.